Okay, last but not least here for chapter 8, let's do some improper integrals. Now here's the deal with improper, right? So there's something that's not going to be quite right, and here's the deal. When you're looking for an improper integral, then the bounds have issues. So there will be bounds. These are definite integrals, but the bounds have issues, so we are going to use limits. And yes, you are going to use limits. Don't try to do this business in your head. Don't try to mess around with not doing proper notation. You are going to use limits here. So do it, because it will make an impact as we move forward. So the bounds have issues. That's what makes this improper with those bounds. Okay. So let's take a look at what's up. If I have this integral, I'm going from a to infinity. So a on to infinity. So I'm going from a to infinity here of f of x. Infinity is the issue. Can I plug in infinity? No. It's what my graph is approaching. It's not what my graph is, some definite value, and that is the issue. So with these infinite intervals, I'm saying as I approach, my graph goes to infinity. What's my graph doing? Yes, it's going on as I get closer and closer and closer there, right? That's what I want to say. It's coming to some value. That's where this b comes in. So here's our process. I can't take some infinity. That's not going to stir the Kool-Aid, Ace. So because of that, I'm going to get some value b where I take that limit and I replace that limit with that b. So instead of it being infinity, I'm taking the limit. So I'm saying, hey, what does my graph approach? As b approaches infinity, what is my graph actually doing? So you can't plug in infinity. That's not mathematically correct. All right? But if I'm looking at these problems and I'm saying, okay, as I go as b approaches infinity, in this instance, what's my graph doing? What's it getting closer and closer to? 0, right? Exactly, my x-axis. So it's getting closer and closer to 0 is what this looks like this particular one is approaching. Okay, so that begs the question here. What if my graph did something like this? As I'm going on here at A, I don't know, and it goes up like this. What's my graph approaching? Infinity, right? Do you see that? So here, yes, I'm looking at this, and then as I get more and more and more and more and more as it goes through there, my graph is not coming down to some particular value, right? It's not my top bound here. I'm finding the area under this region. That's what an integral is. We know that from Calc 1. So what I want to know is from this area under the region, as this is getting closer and closer, it's going to make this finite area, right? My graph is approaching 0, so then that makes this area closed off essentially because it's getting closer and closer and closer. It's so minute that it works. So if I have this area, well, what happens if I go off to oblivion? This area gets all crazy and I have infinite area. Okay, so that's what that's about. All right. Okay, so we're going to learn here. I think I jumped the gun just a tad there. So when it goes off to infinity, it's going to diverge. That's a word that we're going to use. It's down here. If the limits in cases 1 through 3 exist, then it converges. So if it actually has an existing limit, it converges. Otherwise, they diverge. So if it goes off to infinity, your value goes to infinity, then that's a divergent situation. Okay? All right. So let's take a look here. If f is continuous, but instead of going from a to infinity, I'm going from negative infinity up to b, right? So I'm looking from negative infinity. So I have negative infinity, and therefore my bottom bound. Now the variables a and b are used just because that's what your book uses. That doesn't mean that it has to go that way. A is typically on the bottom and B is typically on the top. So if I'm going to negative infinity, then we're replacing the A, the negative infinity, with the A. So that's what's happening there. That's the only reason, is this goes to a negative infinity. A and B are arbitrary, completely arbitrary. You could use any variable you want, right? But they just use A and B, so I just go with that. But they literally have no other significance, so I want to be clear about that. It's just arbitrarily what we use. So if my top bound goes to infinity, then I replace that. If my bottom bound goes to infinity, but I have a number up above, that's the one I replace. Well, what happens if I'm going both directions infinity, yo? You split it up. Oh, it's good stuff, and here it is. So remember, you can pick some number, whatever number you want. I still have A is negative infinity here, and B is positive infinity, but I'm going to pick some number C. Now, here's the deal. You want to pick a nice, easy number, as easy as you can make it. Typically, we want to use 0 because it's a nice, easy number, right? That's the only reason. Because I'm going from negative infinity is at my bottom to infinity. Wherever this breaks off here in the middle, then we want to try to use an easy number, and 0 is what goes with. So again, I just want to point out, if you get some actual value for this limit, that converges. And it converges to that value. If it goes to infinity and it doesn't have a limit, then it diverges. All right. And that's what this image up here is all about, what it would look like to diverge. Okay. Well, you know we're going to do examples, so sit tight. It's coming at you.